Today, I'm going to teach you how to build event-driven microservices using Spring Boot, which communicate using Apache Kafka. So let's get right into it. So let's say you're completely new to Kafka, never seen it before, and you look it up online. You might get a definition that looks a little bit like this, which is that it's a real-time data streaming technology, which is pretty vague and doesn't tell you a whole lot unless you already know a bit about Kafka. So let me tell you the sort of things that it can do. So Kafka can replace a number of existing technologies, and the first one is a message broker. So back in the SOA days, you used to have services, and those services could communicate using a message broker, which passes messages between one and the other. But Kafka can do a whole lot more than that. You can also ingest huge amounts of data using Apache Kafka. You can even stream ingest huge amounts of data using Apache Kafka. And because that data is persisted for a time, or at least it could be, you could use it like a cache as well. And I'm sure there's a whole bunch of different ways that you can use it. But today we're going to be using it a little bit like a message broker because we're going to have events. So events are going to happen, and we're going to place those onto a Kafka topic. And then we're going to have our services subscribe to that topic. So when one goes on, they'll take it off, look at the information in it, and then do something with it. That's a bit vague, right? So let's explore our domain first. So if we were going to do this in the traditional monolith way, what would we be working with? No surprise, we're going to be doing books. You know how I love books. So we've actually used this domain model in other tutorials already. I'll talk you through it quickly now. So we're going to have a system which models books. So we might be a library, we might be a bookshop, something like that. So a book has an ISBN, which is a unique identifier for it. It has a title. When you look at a book, it usually has a title on the front, and a book has an author. Authors are their own entity, right? So they have an ID, they have a name, and they have an age as well. Now, the way that we've got this set up in a traditional domain model is that a book has one author, but an author can have many books. And we do that by referencing the author ID inside of the books table in this case. And then of course the author already has an ID. And in this way, we can have that many to one relationship. So many books can have one author, and then one author can have many books. And this is fine if you're going to implement it as a monolith with a single database. But as soon as you go into the microservices world, things change a little bit. And it might look a little bit like this. There's 101 different architectures you could have. This is the one that we're going to do today. So let's say there's a book publisher, right? And this book publisher publishes new books. They release new books to the market, and that new book is going to have its own title, and it might have a brand new author as well. We want to know about it because we're a library / bookshop / whatever. So this is the way that we've modeled it in the system. The book publisher publishes a book. So that's an event. A new book has hit the market. That event will then go onto a Kafka topic, which we have here, which is books.publish. That'll contain all in the information about the new book and the author. We're going to have a books persistent service and an author persistent service listen to that. They're going to be subscribed to that topic, right? So when the event happens, they're going to know about it. And in the case of the books persistent service, it's going to take the book information and it's going to save it to its own database. In the case of the author persistent service, it's going to take the author information and save it to its database. There's going to be no mixing of information. So there's going to be no author information in the books database, and there's going to be no book information in the author's database. The only exception is that in the books database, there is going to be a numeric reference to the author because you need to know the author of that book, right? And that's the way that we're going to capture it, but nothing more than that. Now, when our services save a book or when our services save an author, that's an event in itself, right? We want to know about that. And we could do anything with that, but we're going to call that a notification, and we're going to put that onto a Kafka topic called notification.created, which is going to be picked up by the notification service. And it's simply going to save that notification to its own database. For all of these different services, books persistence, author persistence, and notification service, we expose a REST API so we can interrogate the information that's stored in those databases. We might have a separate service to do that all together. So you might have like a books persistent service and then like a books reader service, for example. But for the sake of the tutorial today, we just want to know what's in the database. So we're going to expose that via a REST API. And I'm going to give you the code for all of these services so you can run it on your local machine. Let's talk about these databases because you're looking at this going, Aaron, why does each service need its own database? And you're right, the books persistent service has its own database and the author persistent service has its own database. The notification service has its own database, and only that service can access that database. Now, strictly speaking, you could implement it using a schema or a table, but it has to be private to that service. The books persistent service cannot access the author persistence table database schema. And there's two good reasons for that. When you have the data private to each service, You benefit from decoupling, so you can change the table of the book's persistent service, you can change the way the data is structured, and it doesn't have to affect the author persistent service or the notification service. You can actually deploy them completely independently. And the second big reason is that it doesn't need to be a database at all. It could be a NoSQL database, it could be a file store, and each service can choose its own way of storing that information, and it doesn't have to have an impact on any of the other services. Each of your services are then decoupled in the way that they store information, which makes things a whole lot more flexible for you. We're almost ready to take a look at the code, but first let's take a look at what these events look like. So the stuff that's put on the book.publish topic and the thing that's put on the notification.created topic. First, let's do book.publish. And it looks like this. You can see it's JSON and it's typically a set of key value pairs and you have a nested author object there. So the events are going to be JSON, right? And you can see here ID, ISBN, title, all of the fields that were in that domain model from earlier. And we've got our author in there with all of the fields that are on the author domain model from earlier. So that's all the information we need about that particular book being published. And this one for the notification, so we have a message, which is a straightforward string there, we have a timestamp, and then we have the service that it's come from. Really, really generic. These are the events that we're going to be dealing with today. So let's take a look at the code for that first service of the Books Publisher. So here's what you need to know about the Books Publisher service. It has its own database, it's a H2 database, and it's in memory, and we populate that database with information. And we do so using the SQL script. Now, when the service starts up, it uses Flyway to put all of this information into the database. So it creates the table for us and it inputs this information. And we have 100 books and we have 100 authors here. And you can take a look through all of this information available. So once this information is in the database, what does this service actually do with it? Well, it's got a scheduled task here. And what this scheduled task does is every 20 seconds, it's going to take one of those books and authors from the database and it's going to put that event onto the Kafka topic. And this should be a nice way of testing out our entire system and seeing how the different events are going to flow through it. The way that it's dealing with Kafka is in the normal Spring Boot way here. We've got a book publisher service, which we take a look at, has a single publish passing in a book domain object. And if we take a look at the implementation for this, we can see it takes that book object, it converts it into JSON using the Jackson object mapper, and then it uses the Kafka template to put that JSON onto the Kafka topic. If we take a look at that book object, we can see that we've got the ISBN, the title, reference to author, and the author's got its name, age, and its ID. So this is all of the stuff that was in that domain model from earlier, right? The only difference perhaps is that we've given the book a numeric ID here to make it easy for us to increment by one and then just get the next book from the database. So every 20 seconds, it's going to place a book published event onto that Kafka topic. What happens next? So with that event being put onto the Books Published topic, the Books Persistent service and the Author Persistent service are both going to get exactly the same copy of that event, and they're going to do something a little bit different with it. We're obviously going to extract books in the case of the Books Persistent service, and then authors in the case of the Author Persistent service, and save them to their own databases. Now, these services are fairly similar. Let's take a look at the Books Persistence one now. So like the book publisher, this service has its own database, a H2 in-memory database, and we set it up using Flyway. But we can see here the SQL script is much simpler. It simply just creates a table called books with an ISBN, title, and an author ID. So the only constraint is on the ISBN here, which is the primary key. We can't do one on the author ID because all of that information is stored in a different database, and that's by design. So we can't do a constraint, and that can be considered as one of the drawbacks of a microservice approach. So that's our database. Let's take a look at the listener, which is the entry point to this, right? So the listener just listens to that books.publish Kafka topic. It's going to tell us that we've received a book by doing a log statement here, and then it's going to transform it into an object in a pretty roundabout way. So we're basically reading the JSON as a map, and then from that map, we're extracting the values, and we're building up a book domain object. If we take a quick look at that, we can see that it just has an ISBN, title, and an author. We don't care about the numeric ID. These are just the ones that we care about. And we can see that it's not an author object here, it is a long. So the type of the author is a long, which is just going to be that numeric ID. So once we've got our book object, we'll then call the book service, which will simply save that book using a repository. If we look at the implementation for that one, there we go, takes the book object and then uses the book repository to save. And the book repository is using Spring JPA. We go to this, you can see there's no implementation, it implements it for us. And we have the CRUD repository and then the paging and sorting repository extended. We don't technically need this for saving, but this is going to make dealing with our REST API a little bit easier. Let's go back to that listener. So we've saved our book. We've got a reference to our saved book in the database. We can construct a message here saying that a book with this title and this ISBN has been persisted. And we're going to call the notification service to put this notification onto the notification Kafka topic. So the notification is its own object, and you can see here it's got a message, a timestamp, and then the service that it's come from. So all of the stuff that you saw in that JSON object. And the publish notification service, if we take a quick look at it now, is pretty familiar to what you've already seen here. So it uses the Jackson object mapper to take the notification object, turn it into a JSON string here, and then it uses the Kafka template .send to put it onto the topic. And this topic is the notifications topic, which will then be picked up by a notification service. And that's pretty much what this service does, and it's pretty much what the authors service does as well. But of course, this one deals with books and the other one deals with authors. But let's just address that, right? So let's take a look at this book object here, ISBN, title, and author. We've also got a notification object here, message, timestamp, service. That's completely the same in this service. And if we flip to the author service, we can see it's completely the same here as well. You might be thinking, what gives, Aaron? That's not very dry of you. And you're absolutely right. And this is one of the gotchas that comes along with microservices. And that's each microservices implementation should be completely its own. As soon as there is something shared between different microservices, that's a form of coupling. So let me give you an example. Let's say we took this notification object and we put it into a library along with maybe the book object and the author object. So each of our services has exactly the same understanding and access to exactly the same objects. What happens when one service needs something slightly different? Or what happens when the understanding of an author is slightly different in a different service? Maybe we need to add a field, which then all of the services get access to the same field and only some need them. And then what happens when that library gets updated? Well, each of the microservices needs to import the latest library and then needs to be redeployed, which is again a form of coupling. Trust me, before we knew better, I worked on a massive project that was doing exactly this, and it was super painful. So you need to reduce the amount of coupling between microservices as much as you can. Hiya, quick interruption. So I'm trying to make software engineering as accessible to as many people as possible. So if you found this useful, don't forget to like and subscribe, because that really helps us out with the algorithm and it helps us reach more people. And if you have found this useful and you do want to share it with somebody, I'd really appreciate that. Thank you so much. Everything in that microservice is an implementation detail, and it should be hidden from the other microservices. So that's the book persistence and the author persistence out the way. What next? So once the book publisher event's been put on the book published and then picked up by the book's persistence and the author persistence, they will then publish their own events to the notification topic, which will then be picked up by the notification service. Remembering, notification looks a little bit like this, and we've already seen it published in that book's persistent service. So let's take a little look at the notification service, probably the simplest of the bunch, and then we'll look to run these. The notification service follows the same patterns of the other one, which is that it has its own database in memory, H2, and it has a single table called notifications, which has exactly that same information that we had in the event. And we're storing it in a database just so we can query it using the REST API there. If we take a look at the listener, it's probably the next best thing. You'll notice it's pretty similar to what we've seen before. So we take the event off that Kafka topic, which is in the form of a string, and then we use the object mapper to turn that into the notification object. And that notification object is then saved into the database using the notification service, which calls the notification repository.save. And again, that's implemented using Spring JPA. Perhaps the one bit of information that we should cover as well is the controller, which is very basic. We can see here just / notifications, and that exposes a list of notifications or a page of notifications. We're making use of that Spring Boot pagination magic for us. But simply, it's just going to list all of the notifications that are stored in the database. So what's that going to look like when we run it? Let's just go back to the architecture diagram. So I'm going to run the entirety of this on my local machine here using Docker Compose, but more on that in a minute. This is what we're going to expect to see. So the book publisher is going to publish an event every 20 seconds, and that's going to contain book information and author information. It's then going to be picked up by the book persistent service and the author persistent service respectively, and it's going to store those in their own databases and make it available via a REST API. So once they're saved, we should be able to hit the REST API and every 20 seconds see some new information in there for the books or for the authors. Every time it does that, each of these services will be putting messages onto the notifications created topic, which will then be made available via the notification service. So we should see the books database and the author database be built up over time every 20 seconds. And we should also see double the amount of notifications come in because both the book service and the author service is going to be publishing notifications. So let's get to running this in Docker Compose and see it all working. So you see this project contains each individual services. We've got author persistence, books publisher, and our notification service as well. And we've got this Docker Compose file. So let's go through that. So the first service here is Zookeeper, and Zookeeper is needed in order to run Kafka. So there's not a lot of special stuff I need to talk about there. So we've got our broker, and that's our Kafka broker. And we can see here that it exposes 9092 externally, and it exposes 29092, the port 29092 internally. And that's important because that's the port that all of the other services are going to be accessing internally in that Docker Compose network. So this allows us to use Kafka essentially. And then we have our books publisher service, which we're going to build from that source code over there. This has its own Docker file, and we can see it depends on our Kafka broker. And we've got some information in here. This just allows us to use production configuration. If you're more interested on the Spring profiles, I can do a video on that one. But this just allows us to simplify the configuration for tests. And we can see here that we're specifying books.published is the Kafka topic that we should be listening to. And we should be looking for broker on 29092. And it's pretty similar for books persistence. This one is going to be publishing to notification.created, but it's going to be listening to books.published, which is internally. So because it's used as an annotation, we actually just have to specify the string for that. So there's books persistence, author persistence is pretty much identical in configuration. It just builds from a different directory. And then we have our notification service, which of course builds from its own directory, and we'll be listening to the notifications.created topic. Something else to note is that we have some port mapping. So each of these services will run on 8080 as per default, but we're going to map them to a different external port. So we can run them side by side and just flip to different ports to access different services. So books persistence is going to run on port 8181, being mapped from a port of 8080. Author persistence is 8282. And we have our notifications, which will run on 8383. Very, very easy to run this. We simply just need to do Docker Compose up. So let's do that now. Now, something that isn't strictly needed on your first run, but if you do run this more than once, you'll probably need, especially if you're tweaking stuff, is this --build. And that's basically telling Docker Compose that every time that it's specified to build, just force a build every single time. And if you change anything, that would just mean that it's picked up. Bit of a gotcha for you there. So let's run this. So Zookeeper started up, and then each of our services have started up as well. Wait for everything to settle down, and then we'll do some new lines. Okay, so with that all started up, every 20 seconds, we should see a new book come from the book publisher service. Now we're logging things out, so we should see it inside of the logs here. That's the first one, which contains a whole lot extra because then it does its first connection to Kafka. So let's just do some few new lines just to get a cleaner view. So we can see here, the book publisher published the book, The Beyond the Horizon. We've got our books persistence service, which has received the book, and we can see the JSON for it there, Beyond the Horizon, with the author, Adam Parker. And it looks like the author persistence is done exactly the same, picking up the same book. There's Adam Parker. And then we have the notification service, picking up the notification that both the author, Adam Parker, has been persisted. Oh, and that's a notification telling us that it's persisted it. And notification Beyond the Horizon has been persisted. And then the notification service has persisted that as well. And we can see the next book in the list, The Last Ember, has triggered as well. Couple of new lines, and there's the next book. So let's start hitting these REST APIs and seeing what we're getting. And we'll start with the books service, I think. So over to Postman. Right, so remembering that the book service runs on 8181 and it has a single endpoint which lists all the books, which is /book. So if we hit this, we should expect to see a list of books. Let's send this. Very nice. So The Shadow in the Attic, Beyond the Horizon, The Last Ember. And we can see that they've been persisted with the ISBN title and then that numeric reference to the author, which will match what's returned by the author service. So if we scroll down to the bottom, we can see the number of elements is 7. And if we wait a couple of seconds and re-hit it, we should see that number of elements increase by 1. There we go. Number of elements is now 8, and that will happen every 20 seconds when a new book is added. So let's just take a look at the author's service. Running on 8282, and its single endpoint is authors. There we go. We can see there's a numeric reference to the author, which will match what's stored on the book service. We've got the name here, which is Abigail Rose, and age of 80. Adam Parker, Adeline Rivers, Aidan Knight, etc., etc., etc. And we can see the number of elements is currently 9. If we wait a couple of seconds, we should see that creep up to 10. There we go. The number of elements on the authors is now 10. There are 10 authors in that database. So let's take a look at the notification service now. And we should see that run on port 8383 with a single endpoint, which is notifications. Okay, so we can see that the book, The Shadow in the Attic has been persisted, and there's its ISBN, and there's a timestamp that it happened, coming from the book's persistent service. We can see near enough at the same time that the author Abigail Rose with the ID of 1 was persisted, and that's by the author persistent service. And we can see each of the notifications growing and growing and growing. So the number of elements is currently 20. So we can see the total elements is currently 24, and we can see that it's just increased to 26 there. So it looks like each file services are doing exactly what they intended to do. Let's just do a very quick recap. So we've seen here the book publisher service every 20 seconds is putting an event onto the book published topic. We can then see that the book persistent and author persistent services are picking up on that event. They're subscribed to that topic, so they know about that event. They take the information that they care about, and then they save it into their respective databases. We then see that they also publish notification. That goes onto the notification topic, and then that's picked up with the notification service, which puts the notifications in its database and exposes them via the REST API. And this is a very basic example of how you can build event-driven Spring Boot microservices communicating via Apache Kafka. And as per usual, all of the code for all of these different services are going to be made available to you, so you can download it and run it on your local machine. I'll push it on up to GitHub, and I'll leave a link in the description below. And there we go. That's how you'd build a very basic set of event-driven Spring Boot microservices that communicate using Apache Kafka. And if I could fit any more buzzwords in there, believe me, I would. Now, if you're more interested in using Apache Kafka from Spring Boot, then check out this tutorial where we do it completely from scratch, and it's more of a deep dive on it. I'll see you over there.